So hello everyone. Welcome back to the channel again. We would do now second question of arrays, and I have decided to make 25 videos and cover 25 questions of each topic, so we can get a clear understanding of every data structure. And once we do that, so I will increase the numbers and make further videos on those topics, right? So this is our second question of arrays. It's a LeetCode 268 called missing number. I would be discussing three approaches. And so coming to the problem, it says that we are given an array nums containing n distinct numbers in the range 0 to n. We need to return the only number in the range that is missing from the array, right? So the problem is very simple. So we are given an array nums of size n, uh, and there is only one missing number in it, and our range is as given is 0 to n, where n is the size of the array. So in our sample input, n is 3, array size is 3, right? So our range is 0 to 3, which is 0, 1, 2, and 3. So in this range, we need to find out which number is not present in our given array, right? So let me walk through this. So coming to 0, 0 we check in our array, yes, it's there, so no problem. 1 is also there, so no problem. 3 is also there, no problem. But 2, it's not present in our array. So we will return 2 as the answer. So I hope the question is clear. And only one number will be missing, rest all will be present in the array. So I would be telling three approaches to solve this. The first two will be basic, so I won't go very much in detail. So yeah, let's start with the first approach. First approach. So coming to the first approach, let me first write the array again. It's 3, 0, and 1, if I'm not wrong. Yeah. So the first approach, we would let me first index it. It's 0, 1, and 2, right? So what we can do is we can make one another array called visited. It would be a Boolean array of size. Size of our array is suppose n. So this will be of size n plus 1. So n here is 3, so n plus 1 is 4 here. So we will take, in this case, make a array of size 4, and initially all elements will be marked false. Okay, let me index it again. And we made the array of size n plus 1 and not n because in the question it stated the range will be 0 to n inclusive. But we know indexing is 0 based in Java. So that's why if we just go on with making n sized array, the indexes would be from 0 to n minus 1. But we need to also keep track of n because n can also be present in an array. Like here you can see 3 is also present in the array and here is 3. So that's why we make a visited array of size n plus 1 so the range so that the indexing is from 0 to n, right? So this was the reason why I made the array of size n plus 1. So after this we would traverse the array. So let me write it again. So our nums is 3, 0, and 1, right? and visited also again. I will write false, 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 false. Let me index it. So first we come to the first array. We traverse the entire array. We see 3 here first. So we go to the visited array and mark it as true. Then we come to the next element in the nums array. We see 0. So we mark 0 as true. Then again we come to 1 and mark it as true. Finally, our loop ends and we get this as our resultant visited array. Now we will just traverse this array and check at which index we have false, right? So here index 2 has false. So 2 would be our answer because while traversing the array, we never encountered 2 and that's why it was false and not converted to true. So we would know which element was missing. So it's simple. There will be only one position where we will have false and we would just return the index of it. So yeah, this was the first approach. Coming to the time and space complexity, since we are traversing the entire nums array, so time complexity will be big of n, and we are also taking an additional space of n plus 1 in making the visited array, which asymptotically is equal to big O of n. So time and space complexity is big O of n each. So this was the first approach. Now let's head over to the second approach. So coming to the second approach, so we would use sorting here. So let's sort this array. So we would get something like 0, 1, and 3. Perfect. Let me index it. So after sorting it, what you can observe is, actually, let's see the state where we have all elements present. Suppose we had 0, 1, 2, 3. Right now, desired thing is this, that all numbers should be present in range. So once we sort it, we would get 1, 0, 1, 2, and 3. And their index would be 0, 1, 2, and 3. So I hope you can see the pattern clearly. If everything were fine, so the index and the corresponding element would always be same for perfect positioned elements. Like here, one index is 1, element is also 1, index 2, element also 2. So like this, if our scenario was perfect and there was no missing number, then both the index value and the element value would always be same. But this breaks when a number is missing. Like suppose we have 0, 1, and 3 here. So in this case, so our index is 0, element is also 0, so fine. That means 0 is not our answer. We move forward. Index is 1, value is also 1. So 1 is also not answer as it's present and not missing. Now let's see what happens. We get index 2. So we expect here should be 2. But what we see is the element present here is 3, which contradicts with the index value. And since there is a mismatch, we would surely know that 2 is missing from our array and we would return 2 as our answer. I hope this approach is clear. So we would just check whether as soon as we are getting the index values and the elements value same, there is no problem. We will keep moving further. But as soon as we encounter a mismatch, like here we got index 2, but the value was 3. So there is a mismatch. And as soon as we find a mismatch, we would return the index value as our answer. So this was the second approach, coming to the time and space complexity. Since we are sorting, so sorting takes n log n time. So time complexity becomes n log n. And space complexity, since we are sorting the original array itself and not taking any additional space, so it's big of 1. So this is the time and space complexity of our second approach. So we can do more better than this. So let's head over to the third approach. So coming to our final approach and the optimal one. So here you can see the first approach. In first approach, the time and space complexity were big of n. In second approach, we improved space from n to 1, but our time complexity got increased to n log n. So what we want is a solution that runs. See, time complexity can't be better than big of n since we need to traverse a entire array. Then only we can have info of all the elements present. So it cannot be reduced. Coming to the space complexity. So we would see how can we do this in constant space without requiring any extra space. Here we did it, but the time complexity got compromised. But keeping the current time complexity big of n, let's see how we can solve this in constant space. So to do this, mm, we would use a mathematical formula uh, which says that suppose we need to find sum of n natural numbers, sum of first n natural numbers to be precise. The sum of first natural numbers we know is there's a formula for it. It's n into n plus 1 by 2. So this is the mathematical formula we would be using. So I can show you also that this also how it's working. So suppose n here is 3. So first and natural numbers, first three and natural numbers will be 1, 2, and 3. These are the so if n is 3, first n natural numbers, that is first three natural numbers are 1, 2, and 3. So to find their sum, we can either go one by one and compute the sum. That is 1 plus 2 plus 3, which is 6. Or we can directly use this formula. So n is 3 here. So substituting the values in this formula, we would get n into n plus 1 by 2, right? So substituting n equal to 3, we get 3 into 3 plus 1 by 2, which becomes 3 into 4 by 2. 2 twos are 4, and it becomes 6. So anyways, we would get the same result either by manually doing one by one summation or by using this formula. So we would be using this formula. So let me change the page. So our array was 3, 0, and 1, right? And we know that only one number will be missing, which is here 2. So, acha, what if our desired scenario is what? Every number is present. If every number was present in the array, all the sum would be simply the sum of all the numbers, which is can be find using the formula. So sum becomes expected sum is 6, right? And we would get this if all numbers were present in the array and none of them were missing. So we would make an expected sum variable, expected sum, and here we would store the sum if of all the numbers if there was none numbers missing. So our expected sum is 6 because if no number was missing, then we should have a sum of 6. So we would just compute it and store it in a variable named expected sum. Now, but we know in our array one number would be missing. So what we would do is, let me index it. We would keep a variable sum initially initialized to 0, and we would traverse the entire array and just sum all the elements. So first we get 3, so sum becomes 3. Next we encounter 0, so no change, sum still says 3. Next we get 1, sum becomes 4. So as you can see, uh, we are getting sum as 4. But if all numbers were present in the range, we should have got 6. So it's simple. To find the missing number, we can just subtract these values. That is, missing number would simply be missing number would simply be expected sum minus the sum we encountered. Because, uh, I mean, hypothetically, we should get this sum if all numbers were present and none of them were missing. But currently, we are getting this sum. So their difference would give us our missing number, right? Because that's the only number from which we cannot reach the expected sum and falling short of it. So this was our third and the optimal approach. I hope it's clear. Coming to the time and space complexity, since we are traversing the entire array for summing the elements, the time complexity is big O of n. And space, since we are just using, a couple of variables and no such extra space is used, so it's big O of 1, which is constant space. So this was our optimal approach. So I hope you liked all the three approaches, and I would be making more videos on as these. So yeah, that's it for today's video, and thank you so much for watching.